Good morning. My name is Saurabh Bharawat. I am going to give seminar on decoders and encoders. The decoders is the logic circuit that accepts a set of inputs that represents a binary number and activates only the output that correspond to the input number. Means wherever we require to convert the data from multiple input to the single output, there we can use these decoders. In other words, a decoder circuit looks at its input, determines which binary number is present there, and activates one output that corresponds to the number. All other output remains inactive. Whenever we are giving the various inputs to the decoder, according to that, at a particular pattern, the output is given. For this purpose, we are using decoders. In its general form, a decoder has n inputs line and to handle n bits and form 1 to 2 raised to n output lines to indicate the presence of one or more n bit combinations. So this formula is used while designing the decoders, where we initially have n number of inputs, and we have to convert this n number of input data into 2 raised to n number of output lines. So if we are having n number of inputs, then we can come up with 2 raised to n output lines with 2 raised to n different logical combinations. The basic binary function is an AND gate can be used as the basic decoding elements because it produces a high output only when all inputs are high. This is the one of the gate which is used for while designing the decoders, which has a significance when all inputs are high, then only the AND gate will give high output. So for this purpose, we are using AND gate mostly in decoders. This is the basic diagram of AND gate. How it works, I will show you. Initially, this is the AND gate. This is NOR gate. We are connecting four inputs to the AND gate, where one is connected 1, 0, 0, and 1. Instead of 4, 2 are connected through NOR gate. So at the end of the connection, we are giving 1 as the first input. 0 is converted to the 1 through NOR as the second input. Third also 0 is converted to 1 as the input, and last one is directly we are giving to the AND gate. So here we can see all inputs are high. So at this instant only the AND gate will give high output. So this is how AND gate works. And another this is the nomination we can give. A0, A1, A2, A3 are the 4 input lines, where A0 is the least significant bit and A3 is the most significant bit. And like this way we can create a logic to convert the 4-bit data to single bit. You can see initially we are giving 1, 0, 0, 1. If this input is given to the AND gate, then output will be 1. This is one combination. Likewise, we can use various combination to develop decoder. This is the basic diagram of decoder, where n inputs are given to the decoder, and that is, we are converting this n number of inputs to the m number of outputs. Means when all these inputs are given to the decoder, then only one output line will give the output. Every output has its own combinations. So depending on that, the decoder generates the output. There are 2 raised to n number of possible input combinations from A0 to A raised to n. And for each of these combination, only one of the n inputs will be active high. All the other inputs will be low. If an active low output means one of the output will be low and the rest of the all outputs will be high. At this condition, it is required for each decoded number the entire decoder can be implemented with NAND gate and inverters or inverters. Means we can use NAND gates to generate a decoder for active low output applications. Likewise, active high outputs also we are getting from some applications. Active high means one of the output will be high and the rest of the one of the input is high and others are low. At these conditions, we require AND gates and inverters. By using these two devices only, we can develop our own decoder. This is the basic diagram of 2 to 4 line decoder, in which A and B are the two inputs, and we are decoded it to 4 bit output. It's D0, D1, D2 and D3. Here E is the enable input, which is provided to every AND gate, which is used to enable the AND gate operations. Means we know the basic principle of AND gate, that if all inputs are high, then only the AND gate will give output high. So this is the logic we are using here. A and B are the two main inputs we are giving to the our decoder. Here we can see a truth table of the decoder. Because initially we are giving enable 1. It is converted to 0 through NOR gate and it is provided to every AND gate. So initially we are having 0 0 output for A and B. Then the output for D0 AND gate, we can see one input, both inputs are 0, means all inputs are 0 actually. So it is giving 0 output. And for D1 it is given as 1, 1 and 1. So it is giving high output. D2 also having the same condition and D3 also. So from this we can see if all inputs are 0, then we are getting this code 0, 1, 1, 1. So by this way we can decode our own logic as per requirement of applications. As per requirement means if 3 inputs are available, if we are considering the 3 inputs from the application, then we can use 3 to 8 line decoder, which is constructed like this as shown in the diagram. These A, B and C are the inputs and these are given to the 8 AND gates. So these 8 AND gates are having 3 inputs, which is A, B, C, and 3 NOR gates are also used for various combinations, to generate various combinations. This is the truth table. You can see C, A, B. First initially we are giving 0 to all. So at this condition only O0 AND gate is giving high output. Means O0 is having all inputs high. So this is the idea behind the 3 to 4 decoder. Now this is the example of 3 to 8 bit decoder. This code it has a code 74138. There is an enable function on the device, a low level on which each input E1 dash and E2 dash, and a high level on the output and the input E3. This is required in order to make the enable gate output high. So, and another point we can say the enable is connected to the to an input and each NAND gate in the decoder. So it must be high for the NAND gate to be enabled. So E1 dash, E2 dash and E3 are used to enable the AND gates. So if we want to disable or enable, we can control our decoder by these 3 inputs. If the enable gate is not activated, then all 8 decoders output will be high regardless of the states of the 3 input variables A0, A1 and A2. This is the basic block diagram of logic or we can say logical symbol for a 4 line to 16 line. If we are having 4 input lines, then we are getting the 2 raised to 4 means 16 output combinations. And we are having here also we are having one enable input which used to enable or disable the device. This is the basic construction of the 4 line to 16 line decoder, which is constructed using 3 to 8 decoders which are connected back to back. Here we can see X, Y, Z are the 3 inputs and W is used to enable the 2 decoders. And by using these 4 inputs and their combinations, we can generate 2 raised to 4, that is 16 output combinations. When W is equal to 0, the top decoder is enabled and the other is disabled. The both decoder outputs are all zeros and the top 8 outputs generates minimum terms, means 0, 0, 0, 0 to 0, 1, 1, 1. When W is equal to 1 means its unable conditions are reserved. The bottom decoder output generates the main term 1, 0, 0, 0 to 1, 1, 1, 1. While the output of the top decoders are all zeros, because we are disabling the first decoder here by using this NOR gate. We are providing a 0 here, so it is disabled, and we are providing 1 here, so it is enabled. So these outputs are given out, and when we are using this decoder, then this decoder is enabled by providing W as a 0, means 0 is converted to 1 and it is enabled to first decoder, and 0 is directly given to the second, so it is disabled. So like this way we can generate 16 combination of output by receiving the 4 inputs only. Decoders are used in many types of application. One example in the computer in computers for input-output selection, as in previous slide. In input-output selection means in computers we have to receive some data or transmit the data. For that purpose we can use these decoders. Computer must communicate with the variety of external devices like peripherals by sending or receiving data through what is known as input or output ports. Each input and output ports has a number called as address, because we are providing the data by saving it to the specific address, and we are accessing that data by using this address only. So it is very much important to have the combination for this address, which is uniquely identifies it. When the computer wants to communicate with a particular device, it issues the appropriate address code for an input-output port to which the particular device is connected. The binary port's address is decoded and appropriated decoder output is activated to enable the input-output ports. The binary data are transferred within the computer on the data bus, which is set for parallel lines. These parallel lines we can see in this diagram. These are the parallel inputs are given to the decoders. This is the main construction, and like this only we are having in computers also. The input lines are connected parallel, and parallelly we are receiving the input ports, which are converted to the output port wherever we require. So like this way the decoder works. A decoder are used whenever an output or a group of outputs is to be activated only on the occurrence of specific combination of input levels. When we are accessing a specific address or data, for that a specific input is given. That input indicates that we want a specific address data, and that address is given as an output by the decoder. These input levels are often provided by the outputs of a counter or register. when the decoder inputs comes from a counter that is being continuously pulsed, the decoder output will be activated sequentially, and there can be used as a timing or sequential signals to turn device on or off in specific time. In computers, we are frequently using this timing and sequential signals, which is required to activate a specific device which is connected to computer at a specific time. For that purpose, we have to develop a decoder to address that particular timing or that particular sequential signals to generate to activate that device. Let's take an example of an LCD, simple LCD display. So LCD display. In LCD display we have let's take a 7-segment LCD display. In 7-segment display there are 7 LEDs are there. Here we can see A, F, B, G, E, D, C. These are the single LEDs which are arranged in a particular manner, which shows the whatever the required outputs. Means if we want the output in numerical data, then like this the arrangement is done. And if we want, we can take a hexagonal data also, like A to F we can get. The most digit equipment has some means of displaying information in the form that can be understood by the user. This information is often numerical data but also the alphabetical data. One of the simplest and most popular method for displaying numerical digits is used as a 7-segment configuration to form a digital character 0 to 9. You can see these are the 7 inputs. 7 inputs are given to input is given to the decoder, and decoder gives the output of in the form of 7 LEDs. These are for specific input code, specific LEDs are glown, which create a number which we can see and we can receive a data. Means by seeing it, we can analyze the data. What is the input is coming, we can analyze. For many instrumentation industries, or for development of instrument, we can use this 7-segment decoders as a part of the instrumentation. Any combinational logic circuit with n inputs and n outputs can be implemented with an n to 2n line decoder or M-OR gates. We have a procedure. First, we have to express the Boolean function in sum of minimum terms. Minimum terms means that the minimum output required by the application. These minimum terms indicates these are the unique outputs which we can get from our decoder. And second step is we have to choose the decoder to generate all the minimum terms of the input variables. And the third step is the selection of input to each OR gate or the decoder output according to the list of the minimum terms of each function. Means the connection should be done like this, that we can get a particular output when the respective input is given to the decoder. Now second part of this seminar is encoder. We already understood that what is decoder. Decoders are converting n number of inputs to the 2 raised to n number of combinational outputs. The reverse operation we are doing in encoders. And encoders is a combinational logic circuit that essentially performs a reverse of decoder functions. An encoder accepts an active signal in one of the inputs representing a digit, such as a decimal or octant digit, and converts it to code outputs such as binary coded BCD number or the binary number. Means initially in decoders what we are doing is we are receiving multiple inputs and we are giving a specific individual output. And in encoders, we are completely reversing this operation, means we are getting a particular input, a single input, and we are converting it into the binary data which will be used for the particular application in computer. It is useful for software. Softwares are using binary data. So we can receive the data from the other device which are connected to the computers, and it encodes into the binary data which is used to be processed. Encoders can also be devised to encode various symbols and alphabetic characters. The process of converting from familiar symbols and numbers to coded format is called as encoding. Most decoders accept an input code and produce a high or low at one and only one input line. Means by receiving only one input, we can generate a code, a multiple output code. Means we can say multiple bit output code we can generate. In other words, a decoder identifies, recognize or detect a particular code. The opposite of the decoding process is called as encoding and is performed by a logical circuit called as encoder. An encoder has a number of an input lines, only one of which input is activated at a given time and produces the n-bit output code depending on which input is activated. We know that we are saving this in computers. We are saving some data at a particular address. That particular address has a bit data. Address means that bit data. If we are accessing that data, means we have to call that address number. That address number is in binary code. So if externally we are giving input from keyboard to the computers, we are pressing one alphabet or numerical data. That numerical data is received by this encoder, and encoder encodes the data into the binary, which will indicate that address, and that data which is saved to that address, which will we get from there. This is the basic sorry. This is the basic encoder diagram. You can see these are the M outputs we are giving to the encoders, which is in which only one is high at a time, and these are the n-bit output code, which a particular wherever we are getting high, that codes will generate into this all output lines. This is the logical circuit for octane to binary encoders. Means octane means 8 to 3 lines. 8 to 3 lines means we are having 8 input and we are converting this data to the 3-bit output data. Only one low input at a time. Means here only one is low, then that code is generated. That corresponding code is generated into the 3-bit data. This is the truth table. We can see A0, A1, A2, A3, A4 to A7. These are the inputs, and O1, O2, O0 are the outputs. We can see the first combination. If all inputs are high, then the output will be 0, 0, 0. If one of the input is low here, so for that particular conditions, the output is generated like 0, 0, 1. For third case, we can see the A2 is given as a low signal. Then for this particular condition, we are generating 0, 1, 0. Likewise, for particular conditions, we are converting a particular data. That's why we are using encoders. A low at any single input will produce the output binary code corresponding to that input. For instance, a low at A3 will produce O20, O11 and O01, which is a binary code for 3. Means for third condition we are getting 0, 1, 1. If A0 is not connected to the logic gate because the encoder output always be normally at 0, 0, 0, 0 when none of the input is low. Means this is the by default conditions when we are not using any encoder means we are not in any encoding operations, then the output will be 0, 0, 0, 0. So this is a default condition. For this default condition we are providing this A0 and these are the useful data we are getting, and for particular conditions we are converting a particular output code. Now we can see the design of 4 priority encoders. We know that what is the priority encoders? Priority encoders means we can say that if an oblique condition is there, means we are having a confusing input data that we cannot convert into the output data very easily. So for that we are using this priority encoders. Priority indicates that we are giving a priority to a particular input. Then this priority, according to this priority, the output will be generated. A priority encoder is an encoder that includes the priority function. If 2 or more inputs are equal to 1, at the same time the input is having the highest priority, which input is having highest priority, that will be taken as a precedence. Means here we can see in pink color, this one is also 1 and this one is also 1. So at this condition this D1 has a highest priority, so we are converting this data into 1, 0, 1. In fourth condition we can see these two inputs are having same value, means both are high or both are low. For this condition whatever the priority is given to that input, the data is generated here. The truth table for the 4-line priority encoder is like this. This is the basic construction diagram where we can see the NOR gates are used. This is the AND gate and another NOR gate. This is the inverter. So this D0, D1, D2, D3, these are the 4 inputs we are given, and the 2 outputs, this X and Y, these 2 outputs we are getting from this 4-line to 2-line priority encoders. This is the one example of 74147 decimal BCD priority encoder, where A1 to A9 are the 9 inputs we are giving to the encoder, and we are getting O0, O1, O2, O3. These are 4 digits we are getting as output. This is the truth table. You can see here there are many oblique conditions where the normal encoder cannot take decision or cannot generate a particular code. At this condition we are giving a priority to the particular input, which indicates the output, a particular output to that condition. Means we can see if this condition is cannot detected by the normal encoder, then the priority as per the priority we are generating this code. So like this way we can use the priority by using priority we can overcome the normal encoders. The octant to binary priority example. The 74LS148 is a priority encoder very widely used that has 8 active low inputs and the 3 active low binary outputs. To enable the device, the EI means enable input must be low. It also has a EO enable output and GS group signal output for an expansion purpose. Here we can see EO, enable output, group enable input. These are the inputs to the binary encoder, and these four are the outputs. This is the group folder. What is this EI? EI means active low enable input. A high on the input forces all outputs to their inactive states. This high means when we are giving a input as a high, then all outputs of their inactive state is high. That is the part of enabling the device, enabling the input. Then the EO means active low enable output. Active low. When low is given to the input as an input, then the device is active, output is activated. The output pin goes low when all inputs are inactive, high and is low. GS, active low group signal output. This output pin goes low whenever any of the inputs are active and is low. Like this way we can design our encoder as per application. Like if we are having a 16-bit data and we have to convert it into the 4-bit data, then we can generate our own 16 to 4 encoder. One of the example we can say 74LS148 is the example of 16 to 4 encoders can be expanded to this is normally 8 to we can see previously 8 to 4, that is the configuration of that 74 LS148, but we can expand our as per requirement of application to the 16 to 4 encoder, which we are using this encoder back to back combination. And here we can see the encoder by connecting the EO line, connecting the EO of the higher order encoder to the EI of the low order encoder, and negative O-ring is corresponding binary output as shown in here. This is the basic construction of the 16 to 4 encoder, in which we are using 8 to 4 encoders. We are connected back to back. This enable output is given to the as a enable input to the second encoder. So by this way, this signal is transferred to the second encoder, and as per this respective input, the output will be generated. By this way, we can design our own encoder at very wide range as per application required. We can see one application like a simple numpad, a keyboard on the computer. Here we can see, we know that our keyboard is a matrix of switches. Means if you are pressing 1, means we are activating a particular switch, and that switch gives a higher signal to that particular input, and that input encodes the data and we can see on display that 1 is printed. Means 1 is printed means a particular data is given to the particular binary data is given to the system, and system generates a digital output, which we can see on the display of the computer. Here we can see 1, 0, 1, 2, 3, like this. All switches are connected in a grid form, and these individual inputs are given to the encoder as a 9 inputs, and which we are converting into the 4 inputs. So this way we can use. All BCD complement lines are high, indicating O, 0. No encoding is necessary for this. When one of the key is pressed, the decimal digit is encoded to the corresponding BCD code. The key are represented by the 10 push button switches. each with a pull-up resistors to V plus. The pull-up resistors ensures that the line is high when a key is not depressed. When a key is depressed, the line is connected to ground and the low is applied to the corresponding encoder inputs. So as we can see a particular to the particular input, when we press the key, the signal is given as a low or high, and from that data the encoder generates a specific code for that condition. The zero key is not connected because the BCD input represents zero when none of the other keys is depressed. Zero is a by default condition, means zero means we can directly give the output as 000 binary. So we do not need to connect that zero to the as an input to the device. The BCD complement output of the encoder goes into the storage device, and each successive BCD code is stored until the entire number has been entered. So as we have seen the basic construction and working of the encoders decoders, which we are using in data transmission applications, where we have to connect the two devices and we have to form a communication between these two devices. These encoders and decoders plays a very important role. So in communication between the two devices, encoders and decoders plays a very important role. Thank you.